In this video, we're going to look at how to make a third-person character controller in Godot using C#. The controller will support features such as smooth movement, jumping, camera collisions, and shooting. It's based on the third-person controller from Code with Tom, who did it in GDScript. If you haven't checked it out, I'll leave a link in the description. I wanted to do a version using C# because there's not a lot of tutorials for C# in Godot. Hope you enjoy! First thing, you need to make sure you are using the mono version of Godot with C# support. You can download it at the Godot website. I'll leave a link in the description. So the first thing we need to do is create our world, and we're going to do that by creating a 3D scene. And that's going to put a spatial node into our scene. I'm just going to go ahead and rename it to world. The next thing we want to do is we want to create our ground. And we're going to do that using a static body. So let's go ahead and add a static body to our scene. And here you can see it's complaining that we don't have a collision shape. We'll get to that in just a second. Let's first add a mesh so that we can see our ground. So let's go ahead and add a mesh instance. And over here in the mesh instance, we're going to go ahead and make that a plane mesh. Now if we zoom in, we can see this plane mesh here is pretty small. Let's go ahead and scale it 100 on the X and 100 on the Z so that we have a larger plane mesh. And if we zoom back out, we can see it's pretty large now. Now the next thing we need to do is back in our static body, we're going to add a collision shape. And this collision shape here, it's complaining because we don't have a shape resource for it. So we're going to go ahead and make a new box shape. And if we zoom in, we can see the box shape here. Unfortunately, it doesn't match the size of our mesh, and we're going to fix that right now. We're going to take these handles and expand them so that we match the size of our mesh. So let me zoom out here a bit, and we'll go out to there, expand it to here. Now the height of the collision box is a little bit big. I'm going to shrink that down just a bit. And there we go. We have our world. Now that we have our world, we're going to want to save it. So let's do a little bit of maintenance over here in the folders, and let's create in the resource folder, and let's create a folder. Let's create a folder called scenes. And inside scenes, we're going to go ahead and save this scene as the world scene. Save scene as world scene. So one last thing I want to do is back in the mesh instance, I want to go ahead and add a material so that we can change the color. So let's go ahead and add a new spatial material. Let's click on that, change the albedo, and let's give it a greenish color. And now let's go ahead and save our scene, and we're ready to begin work on the player. Now let's create the player character. We're going to do this in a new scene. If you're familiar with Unity, this is similar to a prefab. So let's go ahead and create a new scene here in Godot. We're going to create a 3D scene. And we want the player to be a kinematic body. Right now, when you create a 3D scene in Godot, it defaults to spatial. So we're going to go ahead and change the type and search for kinematic body. I'm just going to go ahead and rename this player. If you hover over this warning, you'll note that it says the kinematic body does not have a collision shape. We'll go ahead and fix that in just a bit. So let's go ahead and add a child node, and we're going to add a spatial node. And we're going to call this the camera pivot. And then under camera pivot, we're going to add another node, a child node. And we're going to search for spring arm. We're going to add a spring arm. And we're going to rename this to camera boom. And finally, we're going to add the camera at the end of the camera boom. Okay, back onto the player. We're going to go ahead and add a child node. We're going to add a mesh instance for the player. And we're going to make it a capsule. We're going to open up the transform, and we're going to rotate it by 90 degrees on the x-axis so the player is facing up and down. The next thing we're going to do is we're going to add a collision shape. And the collision shape is also going to be a capsule shape. And we're going to come to the transform and we're going to do the same thing. We're going to rotate it by 90 degrees so that it matches the mesh. Finally, we're going to come back to player. We're going to add another mesh, and this is going to be the head of the player. So we're going to go ahead and create a mesh here, and we're going to make this one a cylinder. Come into transform and rotate it by 90 degrees. And we're going to change the radius to 0.5 and 0.5. We're going to come over here. We're going to raise it up to about there and push it out a bit. Another thing I'm going to do is I'm going to add a material to this, a spatial material, so that we can change the color. Come over to albedo and let's make this a bluish color. And this is where the bullets are going to shoot from. In order to do that, we need to add a spawn point, and that is going to be a spatial node. So we're going to search for spatial. And let's go ahead and move that spatial node to right about there. That's where we're going to instantiate the bullet. One last thing we need to do is we need to change the player collision layers. The reason for that is the camera boom is going to be colliding with objects in our scene, and we don't want the camera boom to collide with the player itself. Right now we can see the player is on the first layer. We want to move the player over to the second layer and have all the static objects and dynamic objects that we're going to be interacting with in the scene on the first layer. So what we're going to do is we're going to come into project, go to project settings, scroll all the way down to layer names and select 3D physics. Here you can see all the physics layers are currently unnamed. In layer 1 we're going to put all the environment objects, the static and rigid bodies, so let's give it the name of environment. And in layer 2 we're going to put the player's rigid body. So go ahead and click close. Now we can come back into our scene. We can click on player and we can look at the collision layers here. Now if you click on these three dots here, you can see the new layer names. If you don't see the new layer names, you can click away and then click back to player and the layer name should appear. We're going to remove the player from the environment layer and we're going to add the player to the player layer. The mask we're going to just leave on the environment layer. And then the camera boom, we just want to make sure the camera boom is, the collision mask is sitting on the environment layer. What this will do for us is it will allow the camera boom to interact with objects, static and dynamic objects in the scene that are sitting on the environment layer, and it will not interact with the player. We don't want the camera boom to collide with the player itself. So before we start writing the code, as I said, we're going to go ahead and save this scene as a player scene. Again, this is like, for those of you that have used Unity in the past, this is like saving it as a prefab. And then if we come back into the world, we could actually add our player scene. And if we zoom in, there's our player. So I'll go ahead and add the player right about there. Now let's create the bullet scene. Again, if you're coming from Unity, this is basically a prefab. So we're going to come up here, click on new scene. It's going to be a 3D scene. Now the bullet, instead of having the top node as a spatial node, we're going to change it to a rigid body. and let's call this bullet. Again, we have a warning here that states that we are missing a collision shape, so we'll go ahead and fix that right after we add the mesh. So let's go ahead and add a mesh instance so we can actually see the bullet. It's just going to be a simple sphere. Now, I would like to scale this sphere down. It's a bit big, so let's make it 0.5 in every axis. And we're going to go ahead and now add our collision shape. And this will be a sphere shape. Now, one thing about Godot is you generally do not want to scale the collision shapes using the transform matrix here. Rather, you need to scale it using the handle. So we're going to go ahead and scale it to match the size of the mesh. And we're pretty much done. Now, as far as the bullet is concerned, there's two different ways to destroy the instances of the bullets as they're being fired. I could add a script to each bullet, which will, after a certain amount of time, destroy the instance. However, I'm going to do it a slightly different way, and we will see that next. So let's go ahead and save this scene in our scenes folder, and we're going to call it bullet scene. Now that everything's set up with the player, we're ready to finally write some C#. Let's go ahead and save the scene, right click on player, and we're going to attach a script. Now, in the language drop downs, make sure you have C# selected, and in the path, we're going to save the script to scenes player.cs. Go ahead and click create, and we are ready to code. First, we delete the default comments, then we set up the variables that will contain the various attributes of our player, including the speed, the acceleration, air acceleration, which is the acceleration when the player is falling through the air, the gravity, which we need to control because the player is a kinematic body and not a rigid body. We also define the max terminal velocity, which will limit the maximum speed a player can fall, and finally the jump and shoot power, which controls the force applied when we jump or shoot a bullet. Also notice I've prefixed each variable with the export attribute. What this does is allow me to edit the value of the variable inside the Godot editor. Let's add a couple more attributes. We need a mouse sensitivity variable, and I'm again using the export attribute, but this time with a property hint that will tell the editor to limit the range between 0.1 and 1.0. We also need a minimum and maximum pitch for the camera when moving the mouse, again using property hints to limit them between -90 and 0 for minimum pitch and 0 to 90 for max pitch, with a step size of 1. Finally, we need a few more variables that will hold the velocity and node objects from our scene. The vector3 velocity will keep track of player velocity, and the y velocity float is just for convenience to help keep track of the player's vertical velocity. We also need a reference to the camera pivot and the camera nodes. We need a reference to the bullet scene that we created earlier and the bullet spawn point. In the ready method, which gets called shortly after the player node is created and is ready, we now assign the nodes to the reference variables. We assign references to the camera pivot, camera, and bullet spawn point using the getNode functions. Since the bullet scene is not a node but rather a packed scene, we use the load method of the resource loader class to load the bullet scene. Finally, we capture the mouse input. We can now move on to the process method, which gets called every single frame. In this method, we use the isActionJustPressed method of the input class to poll for the UI cancel input, which by default is assigned to the escape key. When escape is pressed, we will release the mouse cursor by setting the mouse mode back to visible. Now we need to handle mouse motion events so that we can rotate the camera when we move the mouse. We do this by creating the input method that gets called anytime Godot detects an input event. Inside this method, we first check to see if the captured event is a mouse motion event. If it is, we take the player's current rotation transform in degrees and save it to a temporary vector3. We then take the relative movement of the mouse in the horizontal or X direction and subtract it from the player's rotation about the Y or vertical axis. We then write the changes back to the player's rotation transform. This allows the player to rotate left and right. We do the same thing for the camera pivot so that we can get up and down movement. First, we take the camera pivot's current rotation transform and save it to temp vector 3. We then subtract the relative vertical mouse motion on the y-axis multiplied by sensitivity from the camera pivot's rotation about the x or horizontal axis. We then clamp the rotation so that we limit it to our min and max pitch. We then apply the rotation to the camera pivot. Now we need to handle player movement. We're going to do this in the physics process method because we want movement synced to the physics engine, and Godot calls this method at whatever frame rate the physics engine runs. We will define a separate function called handle movement that gets called every physics frame. Before we write this function, let's set up the input key map in Godot. Back in the editor, we're going to go to project settings, we're going to click on input map, and we're going to add a couple of actions. We're going to add forward, backward, left, right, and shoot. Now you see them down here. What we're going to do is add a key for the forward, add a W, click OK. Backward is going to be S, left will be A, right will be D, and the shoot will be the left mouse button. Back in the code, we can now write our handle movement method. I am declaring it as an async method, and you'll see why in just a moment. So first we declare a local vector 3 to hold the direction and default it to a 0 vector. Then we check for the input key that was pressed and add or subtract the player's basis vector based upon the key pressed, remembering that the negative z-axis is forward in Godot and the x-axis represents horizontal left and right. We then normalize the vector so that we move a consistent speed in all directions. So for example, if you press the forward and right key to move diagonally, you're not going to be moving faster than you would just in the forward direction alone. Next we check if the player pressed shoot, and if so, we instantiate our bullet scene and add it to the root tree. Then we set the global position of the bullet to that of our bullet spawn point, and finally apply an impulse multiplied by the shot power and -1 for the forward direction. And we add our current player velocity to the impulse so that if we are moving, the velocity is added to the bullet. Next, create a dynamic timer, which is equivalent to a yield in GDScript, to wait 5 seconds before destroying the bullet. Finally, if the mouse pointer is not currently captured, we capture it. One thing to be aware of is the C# await operator is only able to suspend execution of asynchronous methods, which is why we declare the handle movement method as async. Finally, we handle acceleration. First, define a local float. If we are on the floor, assign it the acceleration value. Otherwise, it gets the air acceleration. We then linear interpolate the velocity of the value of direction times speed by the weight of acceleration times delta. Then, if we're on the floor, we're going to set the y velocity to a very small downward force. This will keep the player on the floor. Otherwise, if we are in the air, we clamp y velocity minus gravity to the max terminal velocity. Next, we check for a jump. And if we are on the floor, we set the y velocity to the jump power. Then set the y component of the velocity vector to the y velocity. Finally, use Godot's move and slide function to move the player and pass in the velocity vector and the up vector. We are now done with the C# character controller. Save the code and go back to the editor. So back in our editor, let's open up the world scene. And let's zoom out just a bit. We're going to add some more objects to the world. So let's go ahead and add a CSG box. And we're going to drag it over here, grab the handles, and expand it just a bit. And it's important that we click Use Collision. We enable Use Collision on the CSG box. Let's add another one. This one I'll drag over here. Let's make this one a little bit taller. And finally, I'll add a third one. This one I'm going to push over here. I'm going to make it really tall and wide. And I'm going to also add a material to this CSG box. We'll go ahead and add a spatial material. That way we can change the color, come to albedo, and let's make it kind of a darkish color. And then for this one here, we'll do the same thing. Spatial material, change the albedo, make this a dark blue, and then finally the first CSG box. Let's add a material, come into albedo, and I'm going to make this one kind of this color here. And one thing we forgot to do is we forgot to define the jump key map. So let's go ahead and do that. Come over to project settings, come back to input map, and let's add a jump action. And with this one, we're gonna just press the space key. Now let's hit play, and it's gonna ask that you define a main scene. So we'll go ahead and select our world scene. And here we are in our game. We can shoot, we can jump, and what's really cool is that spring arm. When we go up against the wall, you can see that the camera does collide with the wall and it moves on that spring arm that we defined earlier. And after 5 seconds, the bullets will disappear. They will get destroyed. And there you have it, a third-person controller in Godot using C#.